Hi there, my name is Dimitris Haralambidis, I'm an IB and SAT mathematics teacher, and in this video our topic will be integrals with initial boundary conditions. The main concept of this video is the following. Given the derivative f prime of a function f and one condition that is satisfied by the function f, we will be asked to find the function's formula. In math symbols, all I've said could be expressed as given f prime or dy over dx, it's the same thing, and the condition of the form f of a equals b, which means that when x equals a, y equals b, then we need to find f of x, or it might be asked as well as find y in terms of x or find y equals f of x. Let's move now to the methodology. The methodology followed in these cases is really a quite easy one. Thinking of the way we define the antiderivative of a function, we always begin by the fact that f of x, the function f of x, can be expressed as the indefinite integral of f prime of x dx. We already know that once we are done with this integral, every time we calculate an indefinite integral, there should be always a constant c at the end. And that's exactly where the condition that is satisfied by f gets in. We will apply this condition for the function we have already found, and that substitution will lead us to find the value of c. Once there, we are done. We have managed to estimate what we needed, the formula of the function f. Let's work some examples to make it look even easier. Given that dy over dx equals 3x squared plus 5x minus 2, and that the graph of y equals f of x passes through the point with coordinates 2 and 10, calculate y in terms of x. As I mentioned earlier, our first step will be to start with the equation f of x equals indefinite integral of f prime of x dx. In our case, f of x will be equal to the indefinite integral of 3x squared plus 5x minus 2 dx. If we apply appropriately the integration techniques we already know for the polynomials, we will find that f of x is equal to x cubed thirds plus 5 times x squared over 2 minus 2x plus c. So, how exactly will we find that constant value c? We've said that we will now use the condition that is given. Here, we were told that the graph of y equals f of x passes through the point 2, 10. And what does that mean? We know that a point lies on a graph when the coordinates of that point satisfy the equation of the corresponding function. So, in more simple words, if x equals 2, y equals 10, or f2 equals 10. This means that I will go to the formula I have already found for the f of x, and I will substitute 2 and 10 in places of x and y respectively. So, that would lead me to write the equation 10 equals 2 cubed thirds plus 5 times 2 squared over 2 minus 2 times 2 plus c, which eventually leads to the value of c being 4 thirds. So finally, f of x will be equal to x cubed thirds plus 5 times x squared over 2 minus 2x plus 4 thirds. And that's the function I was looking for. Let us see now a second example. This time we are given the second derivative of f, not just the first one, but we are still looking to find f of x. So given that second derivative of f is equal to 2x plus 1 and that the gradient of f at point 2, 5 is 6, calculate f of x. As I just said, here we are given the second derivative and are still asked to find f. This only means that I will have to do the same as before. I will have to apply the previous methodology, but this time I will have to do it twice. I will begin by first calculating the first derivative and then f. So, exactly as I did before, I will start with an expression that includes the first derivative and the second derivative and an indefinite integral. This time it will state that the first derivative of x is equal to the indefinite integral of second derivative of x dx, which in our case is equal to the indefinite integral of 2x plus 1 dx, which can be easily found as x squared plus x plus c. I need to find the value of c. To do that, I need to find a condition that is satisfied by the first derivative of f. Let's see what we've got. We were told in the beginning that the gradient of f at point 2.5 equals 6. Well, remember that by gradient of f, we basically mean the value of the first derivative. So, gradient of f, f prime, at point 2.5 at x equals 2 is 6. So basically f prime of 2 equals 6. This means that I will go to the formula of f prime I have found and I will plug in 2 and 6 in places of x and y respectively. This will lead me to the equation x equals 2 squared plus 2 plus c, which leads to the value of c being equal to 0. And that only means that f prime of x is equal to x squared plus x. Now I will have to do the same, but this time for the first derivative. I will still begin by that expression, f of x equals the indefinite integral of f prime of x dx, which is equal to the indefinite integral of x squared plus x dx, which can be found as x cubed thirds plus x squared over 2 plus c. I still have a new constant this time. That's the important thing here. I simply used the same notation. Instead of using another letter, I still used the letter c. But that does not necessarily mean that c has to be equal to 0 because I found that the value of c was 0 before. It's another constant, it can be any number. So, to calculate that, we need a condition that is satisfied by f this time. What do we know? We were told that the graph of f passes through the point 2.5, which means that f of 2 equals 5. Therefore, I will go to the formula of f of x I have found, and I will plug in 2 and 5 in places of x and y respectively. This will lead us to the equation 5 equals 2 cubed thirds plus 2 squared over 2 plus c, which, after solving, will lead to the value of c being equal to 1/3. So, here we are. F of x is equal to x cubed thirds plus x squared over 2 plus 1/3, which is exactly what I was looking for. And that would be all. For any questions you might have regarding the content we just viewed, or any possible collaboration, you can always contact me. Don't forget to check my site for more IB and SAT math resources, and of course subscribe to this channel. As always, thank you for your time.